Big time brilliant button programmers, it's Prof G, and we are going to examine a common problem with buttons that often trips up new makers. We're going to see that when you press down on a button, there are actually a lot of button presses that are generated as long as your finger remains down on the button. Now, there are a few ways to fix this problem. We're going to learn what I think is the most straightforward and useful method in CircuitPython. It's called debouncing, and we'll perform debouncing using the Adafruit debouncer library. Now, we're going to have to modify our button code just a little bit, but very importantly, we're also going to note that there are some changes you need to make when working with the internal buttons of the Circuit Playground versus the external buttons that you'll often use in projects. We'll cover all of that, so let's learn big. So plug in your board, then launch PyCharm, and if you're new to the playlist, here's where you can catch up on the goodness that brought us all to this point. Now, to illustrate a problem many electronics programmers experience, let's first create a program that lights up button A when pressed and counts the number of presses. Now, let's keep the code from ifs and buttons that we created in our last lecture. We'll change the comment to bad_buttons. And a quick review, when we work with buttons, we import digital I/O. We'll keep our NeoPixel and our color code here. And down here, we learned to set up our buttons. We need 2 lines. In our first line, we create a digital in/out object, passing in the location of the button. That's board dot and in all caps button_A. And in the next line, it's something that we hadn't had to do with NeoPixels. We specify that our digital in/out object is, in fact, a digital in object because a button is an input device. You press a button and you send a signal into the microcontroller, and then you usually do something. And in between parentheses, when we specify it as a digital in object, with this switch to import function, we pass in digitalio.P pull.down. Now, this simply controls the electronic signal so that we can reliably read the button. The details don't matter at this point in our course, but do know whenever you need to create a software object to represent a built-in button on the Circuit Playground, this is the code you're going to use with the digitalio pull down. Now, in our while true, at the top we had the AND statement that checked to see if A and B were pressed. We don't need that anymore, so I'll remove that. And I'll make our first elif statement an if statement. So the way we read this code is if we press button A, we turn blue, else if we press button B, we turn red, else if neither of these things happen, we turn black. Right now, we're just going to focus on button A. So let's write some code to count up the presses. For that, we need a variable to hold our count data, and our count is going to start with 0. So above while true, I'll enter press_count_A equals 0. So we're creating a new variable here called pressCountA, and we're setting it to 0. When we use a single equal sign like here, we're taking what's on the right-hand side of the equation and putting it in the variable on the left-hand side of the equation. Now, in the while true, whenever A is pressed, we want to increment pressCountA by 1. So we say pressCountA equals pressCountA plus 1. So up here, we assign the value 0 to start pressCountA. Inside the while loop, every time we press, we increment pressCountA by 1. Also, since adding a value to a variable is such a common thing to do in Python, there's a shorthand for this statement. We could also say pressCountA plus equals 1. Both of these lines are the same. Use whichever you like, but know them both. Then let's print out the value of pressCountA to the console and TO so that we can see how many times that button was pressed. Now, we could simply say print and in parentheses pass in pressCountA, but let's get fancy. We're going to use a technique called string interpolation with F strings, and the line we'll use will look like this. Print, and in parentheses, lowercase letter f, then double quotes. In the double quotes, we enter whatever string we want. So here I'll say pressCountA, and then we want to print out the value that's inside of the pressCountA variable. So I'm going to enter curly braces in here. You don't type those a lot except when you're programming, but those are just above the square brackets, above and to the left of the return key on the US keyboard. And inside the curly braces, when I start to type, I can see that code completion can recommend the pressCountA variable for me. So what that F string and the curly brace does is it says you can take whatever variable we put inside curly braces and add that to the string. So what we hope is every time we press the button, we'll see an accurate count. PressCountA1 for one press, after the second press, PressCountA2, etc. But that's actually not how things are going to work, and it has nothing to do with our print statement. Let's save this and try it out. So let's get in the terminal and get into TO, and let's see what happens when we save and we run our code. So I am going to press button A, and we say it turns blue, but holy smokes, we got 88 counts there. You saw I just touched it once. Watch, I'll just tap it a little bit, and now we're up to 124. I'll tap it again. 167. Look at all of those numbers. That is not at all the number of counts that I am pressing the button for. Let's investigate what's going on. Now, as we Sherlock this out, one thing I'm curious about is if the while loop continuously runs while my finger is down. Because if that happens, then it's going to continue to execute the if loop each time, and it's going to count up more presses, even though I'm still holding down my finger. So one way we can check this is by adding a variable to count up how many times my while loop runs. And I'll do this under where I define my press count and set that to 0 too. So I'll name the variable while underscore count equals 0. Then in the while loop, but outdented after the if statement, I'll enter a similar count and print code that I did up here in the if statement. So this will execute regardless of what happens every time we go through the while statement, because we're outdented, so we're not in the if statement, we're indented at the base level underneath the while statement. And I'll say while underscore count plus equals 1, and I'll use the shorthand. That's the shorthand that we'd mentioned up here. You could also say while count equals while count plus 1, and below we'll use our f string, print between parentheses, f between double quotes, while count colon, and then I'll add 2 curly braces, and between the curly braces I'll add our while underscore count variable. And one more thing, learn from experience, your CircuitPython board is so fast that the print statements won't be able to keep up with the processing. They'll run by and it'll be tough to read. So we're going to slow things down a little bit by adding a time sleep of 1/4 of a second just after we print out our while count. So this will allow us to see our results. So we'll say time.sleep and in parentheses 0.25. And now let's open up the terminal, save, and we should start to see there's the while count every 1/4 second. So we see that's the while loop going through. We don't have any counts in the if statement because we haven't pressed yet, but here I go, I'm going to press. And oh, look at this. So we're getting the ifs count up with whiles. So even though my finger is down on the button, and I only want to register 1 press, it's actually registering a press every time it goes through the while loop, because it's true, we can see up here, as it continues to go through, that button A is down. So it's adding up another one, another one, another one, another one. When I take my finger off, then it's just counting up whiles. If I press again, we can see it continues to add up that press count. How can we fix it? With debouncing techniques, my friend. Let's see those. And there are a few ways to accomplish debouncing. I'm going to demonstrate a method using Adafruit's debouncer library that'll register the press only once, so we'll get an accurate count, but it won't hold up the rest of the code. So we're going to keep going through the while true loop. We're not going to halt the code while we're pressing the button. We're just not going to record more than 1 button press as long as the finger's down. And here's how we do it. Now, to get this debounced button goodness to happen, we need to do a few things. First, we need to add an additional library. We're going to add Adafruit underscore debouncer. And since we only need the button class in that library, we'll import it with this line. From Adafruit underscore debouncer, import capital B button. Now, the Adafruit debouncer library also relies on another library called Adafruit underscore ticks, but fortunately, when we install Adafruit debouncer using CircUp, CircUp will also install any support libraries that we need too. Now, another thing that we change is the way we set up our buttons as well. So instead of just 2 lines, we need 3 lines. And Blink is telling us to watch out the 3 variables, all caps button underscore A, button underscore capital A underscore input, and button underscore capital A are all different. It's really easy to confuse these 3 variables. Make sure you treat them as separate things. Now, we've seen this first one before when we say board dot and in all caps button underscore A. This is just the location of the built-in buttons on the CPB. So there's a button A and a button B. Now, when we eventually wire buttons up to boards, we're not going to pass in this button A or button B. We're going to pass in the pin number that we wire a button to. Now, the first 2 lines look the same as the lines that we've written previously, but notice that I've changed the name from button underscore A to button underscore A underscore input. And I'm doing that because in this particular case, I want to call my button button underscore capital A. So that's the name of the button that I was using previously, but we need to do some changes here because it's debounced buttons. Now I'm going to set this button up as an object of class type button with a capital B. This is the class that we imported from Adafruit underscore debouncer above. And what that does is it creates a button that's a debounced button. It's only going to report its state once per press or release. But we need to pass in the initial setup from above, so that's why I call this button underscore A underscore input. So when I set up the button underscore A here and call the button class, I'm going to pass this in as our input here when we create that debounced button. Now also notice there's a second parameter in the button class, value underscore when underscore pressed, and I set this equal to capital T true. So this value is set to false by default, but there's a weird thing happening with the built-in buttons in the CPB. Now you see, when we work with buttons, we're going to use something called an internal resistor. Now, not to get too far into the weeds, but we need to use an internal resistor to make sure that our button reports its presses properly. If we didn't use the resistor, then we wouldn't get an accurate button reading. Now, because of the way the built-in buttons are designed on the CPB, we use this capital P pull dot all caps down resistor here. You'll hear that referred to as a pull down resistor. Most of the time when we work with external buttons that we wire up to a board, we're going to use capital P pull dot all caps up resistor. So pull dot down for CPB built-in buttons, pull dot up for the type of buttons that we wire up to a board. Hopefully that description prevents us from having to dive too deep into what's going on with electricity on our boards. But there's another thing we need to pay attention to with these built-in buttons. Buttons that use the pull down resistor report true when pressed. The default is that a button will report false when pressed. So that's what this second parameter does here. So the shortcut to remember is when we work with the built-in buttons in the CPB, we want to use pull dot down and value underscore when underscore pressed equals true. And when we wire external buttons to our board, we're going to do pull dot up and value underscore when underscore pressed is going to be equal to false, but that's the default, so we can leave out the second parameter for any wired up buttons. Now, one more thing. Each time we check to see if a button was pressed or released, we need to call that button's update method. It's a method. See the parens after it. No parameters are passed into the parens, but this makes sure that we're checking the most current button state. And since this is a debounced button, we only record one press each time it's pressed and one release each time we raise a finger off the button. Now, very important, I've seen lots of students miss this point. You want to make sure that your updates are inside your while true loop. You need to constantly get the state of the buttons. You're not going to get it just once. And by constantly checking update, you can be sure you know what your button's doing. Either it's still being pressed or it's been released. If your update statement is outside the loop, you won't get a continual button reading and your code won't work. Also remember that you need to call the update method on each button you use. So if you have two buttons, button A and button B, you'll have two update lines. So let's go ahead and add these changes to our code. We're going to see how things work. Now we're going to find that our count and our print works great. We're going to run into another snag when it comes to getting the lights to work properly, but I'll show you how we can fix that, and we're going to end up with what I hope is very readable code when we're done. Oh, and before we forget, let's save our bad button code. Always be sure to close the tab at create so you're back at code.py, and then we'll change the comment up top to read debounced buttons. So if we're going to be working with debounced buttons, we need to use the Adafruit debouncer library. So down here, I'm going to say from Adafruit underscore debouncer, and we see that that's not showing up with code completion. Import capital B button. Now the button class is the only thing that we need, so we can specify that with a from statement in here. We won't need to access anything else in the Adafruit debouncer library. This will also prevent us from having to list the name of the library in front of the button class that we want. But we've got an issue here. PyCharm is saying that this is an error. It doesn't recognize what Adafruit underscore debouncer is. It says that this is an unresolved reference. Oh yeah, we've got to import the package into our PyCharm project. Let's go ahead and do that. Go under Settings, Mac under the PyCharm menu, it's under File and Windows. Head into your project, expand it if you need to, and get into the Python interpreter area. Then click plus, and in the search box you can enter Debouncer. A few of them show up here, but you want Adafruit-CircuitPython-Debouncer. Select that, click Install Package, click Close, and click OK. And as expected, the red squiggly underlines of anger are gone. We have no error with Adafruit underscore debouncer. But remember, when you import a new library that is not part of the standard CircuitPython setup, you're going to have to add that to your lib on your CircuitPy board, and we do that with circup. So let's open the terminal, and we see the old code with the while count is still running here. So let's get out of this. And unfortunately, Control QT is not letting me get out of TO, so I'm just going to quit out of PyCharm, unplug and plug my board back in, get back into PyCharm, and now I can see I'm at the prompt in the terminal. And you know what? It's not a bad idea to check to see if we need to upgrade circup. So I'm going to enter pip3 space install space -- upgrade space circup, press return, and it looks like I've got the latest version of circup. So now we can use the command circup install Adafruit underscore debouncer. Press return. Ooh, and I've got a message that I can upgrade my CircuitPython. I'll do that later on, but I can see that this has installed both Adafruit debouncer and also Adafruit underscore ticks. Nice. So now I'll close terminal and let's set up button B as a debounced button. The first two lines of code are exactly the same, but I'm going to change the name of the button to button underscore B underscore input. So I'll just add underscore input to the name of button B here for the first two lines. But then on the third line is where I create the debounced button, where I'll say button underscore capital B. I want to use that as my button name to match button underscore A. And I'll set this equal to the capital B button class. We imported that from the Debouncer library, and we'll pass between parens button underscore B underscore input. So this button class, to create a debounced button, essentially takes in a regular button, then converts that to a debounced button. That's what we're calling button B here. Now, because we're working with a button that's built into the CircuitPython board, we can't use the default false value for the second value. So we actually have to enter a value here. We'll say comma, and then select value underscore when underscore pressed. The default is false, so because that's a default, you usually don't have to enter the second parameter for most buttons, but you do have to enter it for buttons that are built into the board. They're just a little bit different. And I'll remind you of the changes when we work with external buttons in a future lesson. But then the thing that's very important to remember is if you want to get the state of the button regularly, you need to add a line inside of your while true, and it's usually good to do this as one of the first lines. We'll say button underscore B, the button we're working with, dot, and call the update function, open and close parens, and this regularly checks the button. It's like saying, what's up with the button? What's up with the button? What's up with the button? We want to see if it's pressed or released. That can change regularly, so this update function inside while true will regularly update and get the current button status. And you only use that with debounced buttons. Now I'm going to get rid of the else if button stuff that was inside of our if else statement here, and let's enter a brand new if statement below this. It's still outdented at the same level as the if statement above it that will handle our debounced button, button B. So we'll say if button underscore B, and what we check is dot pressed. This also is a Boolean value, true or false. And if it's true, we'll press return, and indented underneath we'll say pixels.fill passing in red. Now also, we don't really need the while underscore count stuff anymore because we've already used that to sort of sleuth out what was happening in the first part. So I'm going to delete while underscore count here, both from where it's defined up top and at the bottom of the while true statement. I also don't need time sleep in here, but I do want to keep track of button B's press count. So I'm going to create a new value below press count A called press count B, set it equal to 0 initially. Then inside my if statement, underneath where it says pixels.fill red, I'll say press underscore count underscore B plus equals 1. That adds 1 to press count B each time the button is pressed. And then we'll put a print statement below this that says print f string in double quotes press count B colon, and I'll put into curly braces, and in between the curly braces we'll pass in press underscore count underscore B. So now let's get into the terminal, and we have to relaunch TO. And we see we're still taking a look at our while count because we haven't saved yet. So let's go ahead and save, and the while count should go away. So now let's press button B. 1, 2, 3. It's only recording one press. Nice. I should have added a space between count and B. But yeah, we can see 4, 5, 6. Now what happens if I press A, the button that's not debounced? Button A is not debounced, it's registering a bunch of presses. One issue we're having is button B will flash red when you press the button, but it won't stay red when your finger's down. We've got to fix that, but at least we've got our count working properly. So let's see how we can fix it to make sure that our button B will stay red while our finger is down on the button. Well, let's take a look. Remember, we said that a debounced button object will only report its state changed once when it's pressed or released. It won't repeatedly report that state change. So in the if here, we correctly increment the count, and we also fill in the lights red, but this complex if statement here has an else clause. And this else statement is going to continue to execute on all of the passes of while true after that first press is recorded. So press is recorded only once, but this else clause is going to fire every other time we go through the while loop until another event is recorded. So that's why we almost immediately see the lights go off. So we're getting the correct count, but this else statement turns off all the lights because after that first press, if button B pressed is no longer true. So with each pass, we say else, pixels black, else, pixels black, else, pixels black, over and over again until button B update records a new event. But the fix is easy because buttons also have a .released property. So first, since we're working with debounced buttons, I'm going to get rid of this if-else statement up here because it uses the old standard button that records too many presses. And I'm going to add below my if statement elif button underscore B dot released colon, and indented below this we'll say pixels.fill passing in black. So let's look at this code. We're constantly checking the button status with button underscore B dot update in the while true. So every time over and over again, what's the status, what's the status, what's the status, that's what this update does. Now when we first start our program, both of the conditions, the one the if that checks if it's pressed, elif to check if it's released, are both false. Now we'll continue to go through the while true, and pressed and release are both false until we press button B. Now when button B is pressed, .update's going to pick that up. At that point, button B.pressed is true, so we execute what's indented below it, we turn the lights on red, and we add 1 to our count. Now while we're holding our finger down, we keep going through the while true loop. Even though we go through this over and over, button_B.update doesn't say that it's pressed a second time. We're still holding our finger down, but even though the finger's down, update only records the press happening once. So pressed is false, but we haven't lifted our finger off, so released is false too. So neither the if nor the elif is executing, but the last thing we did was turn the pixels red, so they're going to remain red until you lift your finger. Button B update picks that up, it records that as a released, so the if statement's not true, the elif button released is true, we turn the pixels black, and they remain off as we continue to go through the loop again and again and again. The release is only recorded once, but the if and elif aren't going to fire again until the button is pressed. Once the button's pressed, the update will pick it up, we'll turn on the lights again, we'll increase the count, and we'll keep going through while true over and over again until the button is released, update picks that up, and the else if turns the pixels black. That's the pattern. It repeats over and over again, elif with the .release property for the win. And you know what? Why don't we convert button A to a debounced button as well? So I'm going to change the button_A name to button_A_input in these first 2 lines. And below this, I want to use button_A as my debounced button variable name, set that equal to capital B button. In parentheses, we pass in the regular button that we just set up of button_A_input, and we pass in a second parameter since this is the built-in button on the Circuit Playground. That's comma, value when pressed equals true. Now, if we want to use button A, we've got to check its update inside the while true as well. So above button_B update, we'll say button_A.update, open and close parens. And let's get button A to do pretty much the same thing that button B is going to do. So I'm going to highlight the whole if-elif statement here, paste it above. I'll make it one big if-elif statement by changing the second if to an elif. But then I'll change the first if and elif so that they refer to button A instead of button B. So button A.press is what we check. We'll do press count A. The print statement will say press count A, and we'll make sure that reports press count A. Also make sure that we change the release here in the elif so that it's button A released. Whoops, and I had a little error in here in the elif. Fix that. Squigglies of anger go away. Looking good. So now let's open the terminal. TO's running. I'll head up top and I'll save. And here we go. And look at this, button B is registering just one press, but keeping the light on while the finger is down. Same with button A. The one goof I made was I copied my code and I forgot to switch one of the buttons to light up in blue. So they're both red, but this code is working great. Let's just fix this. So how about we make button A fill in blue, then we can save and run again. And the counts are now accurate and the buttons stay lit as long as my finger is down. A blue, B red, nice. Let's save this as debouncedbuttons.py to our CircuitPython school folder and close that extra tab so that we're back at code.py on our CircuitPy board. So Legends, you buttoned up that big learning. You demonstrated how standard button code might register more presses than wanted. You learned how to use debouncing to register just one press or release at a time. You learned about printing values using F strings. You learned that plus equals will increase a value by whatever's after the equal sign. And you use time sleep to slow down printed results. Big learning is being acquired by you. Hope you're feeling good about it. Until the next time we meet, continue to hack.